Using science to deconstruct your favorite Ninja Warrior obstacles.
Okay, I see you, Science Ninja!
So before you get started, I just want to warn you, this video is a bit longer than the other ones and it goes into a little bit heavy math. So it might seem a little dry at times, but please stick it out because there's some good info in there. Also, I know some other videos and channels have done some ninja shoe reviews before, particularly the NNL and the Ninja Channel, and both of those are great, so I'm going to link them in the description, but I took a little bit different approach. I took a scientific approach and tried to calculate which shoe is the best, so please be sure to stick this video out and let me know what you think. What is up, everybody, and welcome to another episode of the ScienceNinja Series. Once again, I am Mitch Beatapo, and I am here in the Apex Ninja Lab, and today we are going to be answering a very big question. What is the best shoe for competing on American Ninja Warrior? You want something that's got a lot of traction and sticks to the obstacles, but you also want something that's lightweight, it's got a thin sole so you can feel the obstacles. Really, the shoe is the only piece of equipment that we get to take onto the course, and you want to get every advantage you can, so you want the best shoe you can. In order to answer that question, I'm going to be taking a scientific approach, and we're going to figure out which shoe sticks best or has the best traction or friction on different types of surfaces, so that way you can get the most traction out of your shoe as you're competing on the show. Without further ado, the shoes I tested were the New Balance Zantes V2 Fresh Foam, the Nike Flex Experience RN3, the Nike Wild Trail, the New Balance Minimus 20 V5, the Butora Endeavors, the Merrell Vapor Glove 2, and the Vibram 5 Fingers. Let's see how they stack up. So in order to measure the traction of each shoe, we're going to measure the coefficient of friction between each shoe and various different materials. Alright, to start, let's imagine our shoe is some mass and it's sitting on a slope. If our shoe isn't moving, then there's three forces acting on it. The force of gravity, the normal force from the slope, and the frictional force which prevents it from sliding down the slope. If we do a force balance in the x and y direction, those equations are pretty hard to solve. But if we shift our axes to match the slope, those equations become much easier, and we can simplify down to the coefficient of friction and find out that it's equal to the tangent theta right at which the shoe starts to slide down the slope. So, in order to measure our coefficient of friction, we just have to find the point right at which our shoe starts to slide down the slope of a material. So, to measure that in the lab today, we're using one of our trusty quad steps here. It's got a lot of nice angles on it. We can raise it and lower it in order to get the angles that we need. Also, it's made out of wood, okay, so that's going to be one of our first surfaces that we're going to measure with. We are also using a rubber, okay, it's a kind of rubber surfacing that we use kind of for the floors here. You can see it's got some grooves on it. I don't know if you can see that. Okay, we've got carpet here. We've got a big piece of metal surface, just plain smooth metal. All right, and we have plastic. The inside of this is clean here. Plastic lid, but it gives a nice flat plastic surface. I don't have any plexiglass, but this does a good approximation. It's got that smooth, very slick surface. And then, of course, I've got a protractor here to measure the angle. That's really all we need, so let's get after it. Okay, so that took way longer than expected. Before we get to the results, however, there's a couple things I want to say. First of all, I don't know if you noticed, but I wiped off the bottom of each shoe and the surface before we tested them. And then there's a couple things, some limitations in this study that I didn't account for. First of all, the size of the shoe. Secondly, I didn't account for wear on the bottom of the shoes. And last one is I didn't account for the surface area on the bottom of the shoe. Some of these shoes you'll see have a little bit of arch to them. That's what it is, those are the limitations, but with that said, let's go ahead and look at the results. And finally, here's all the data for our measured coefficients of friction. I went ahead and ranked them all based on highest average coefficient of friction. So what we see is the shoes on top have a greater overall traction on all materials, and the ones on bottom are the worst. So interestingly, what we see is our top three best shoes, the Zantes, the Minimus, and the Vapor Gloves. Those are common ninja shoes. You see a lot of people running in those. Also, all three of those have the same Vibram rubber on the bottom. It's a good hard rubber that seems to be very sticky. So I'm going to go ahead and highlight those 3 shoes as kind of my personal recommendations. And fourth was our climbing shoes, the Butora Endeavors. Next, the both Nike shoes. They're made up of kind of that softer foam material, and we've seen in the past that performs really poorly on Ninja Warrior, and that showed up here. And finally, and most interesting, our Vibram 5 Fingers was actually our second worst shoe. I've seen a lot of people use these, and I say interestingly because it's made up of that same Vibram rubber that our top 3 shoes had. Alright, so there you have it. That is my little experiment with Ninja shoes and the coefficient of friction. I hope this was informative. I hope it was helpful. Again, I was only able to get to about 7 different shoes there, but I hope you see that the tests are actually really easy to do. So go out, test your own shoes. Let's expand this list. Let's get something a little more comprehensive out there so we can help answer this question of which shoe is the best for Ninja Warrior. With that, I'm going to wrap things up. I just want to say again, I hope you learned something. Thanks for watching the Science Ninja series.